Hi everyone, let's see how to implement mod 3 ring counter. Guys, you know the circuit what I have drawn here is a kind of a synchronous counter which you can understand directly, right? And I am trying to use here D flip-flop. So to make implementation of mod 3 ring counter, you have to connect the D1 with Q0 and D2 with the Q1. And to make it as a ring counter, you have to connect the output of Q2 with the input at D0. So we can call this as simply a mod 3 ring counter, right? So if I would like to prove that it's a kind of a mod 3 ring counter, so what might be the present states? Present states might be Q2, Q1 and Q0. And if I say the next states, those will be Q2 next state, Q1 next state and Q0 next state. Okay, so the present states values are 0 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Yes, fine. Next, so now to define the next state values, basically according to our illusion we can write, because if I go with the 0 0 0, see I will directly write, if I go with the 0 0 0 as a value, next state value will be what? Again 0 0 0 only, right? If I am going to have 0 0 1, next state will be, the bits are going to be shifted, right? So next state will be definitely 1 0 0. For 0 0 1, you have to have 1 0 0 or 0 1 0, right? So basically if you think that it is 0 0 1, if I try to shift it, so this bit will becomes here, then these two bits will be shifted, right? I am going to assume that it has 1 0 0. So like this you can able to assume by ourselves, right? So but the thing is, you should not go with this, because as per the diagram you have to go. So what we can do now, so to define the Q2n, Q2n value is the value which is produced by D2, because here D flip-flop, right? D flip-flop means data flip-flop, what it is going to produce after some time, D2, right? But D2 is what? Q1. So simply Q2n means it is D1, sorry, Q1. Q2n is simply Q1. So 0 0 1 1 0 0 1 1. And coming to Q1n is going to be a kind of D1 is going to be a Q0, right? So meaning that Q1n I can be write with help of Q0 directly, right? Q1n Q0, so 0 1 0 1 0 1 and 0 1. What about the Q0n? Q0n is going to be the input of Q2 is going to be, so Q0n is going to be the input of D0, guys, D0, which is going to be get the input from the Q2. So indirectly I am saying that Q0n is going to be Q2. So that is 0 0 0 0 1 1 and 1 1. That's it. So I can say that these are the present states, and these are the next state. So can you able to draw the circuit diagram for this? Yes, state diagram. If I am going to have 0 0 0, it will move to the next state as 0 0 only. If I am going to have 0 0 1, see guys, that is what the difference between the earlier assumption and this assumption, right? If I am going to have 0 0 1, it will move to 0 1 0. If I am going to have 0 1 0, it will move to 1 0 0. So that's the reason you should not go with the assumption, you have to go with as per the given diagram. 1 0 0. If I am going to have 1 0 0, it is going to move to 1 0 0, it is going to move to 0 0 1. Right? If I am going to have, so I think 0 0 1, right? If I am going to have 0 0 1, again it is going to be looping, right? So we'll start with any one. So 0 1 1. Anywhere 0 1 1 is there? No. If I am going to have 0 1 1, it will move to 1 1 0. If I am going to have 1 1 0, it will move to 1 0 1. If I am going to have 101, it will move to 011 011, right? Yes. And what about this one? This triple one. So if I am going to have triple one, it will move to again triple one only, right? This is a corresponding state diagram what we are going to get for this mod 3 ring counter. Why it is calling the mod 3 ring counter? It is going to have repeating for 3 loops, right? Yes. So it will maintain the states of 001, 010, 100. It is going to be repeated continuously. So this is way we can able to implement a mod 3 ring counter. Okay, I hope understood clearly. Thank you.